Alright, in this video for Intermediate Algebra Problem Set 1, we're going to talk about a variety of topics, sets of numbers, properties, expressions, equations, and I hope that you will find all of this to be review. I'm still going to go over it though. The first thing we're going to do is take a look at evaluating an expression. To evaluate means to find the value of. In number 1, I have the expression x squared plus 7x. And I'm going to find its value when x is 3. So that means that I'm going to put 3 in the place of x and square it, and then 7 times 3 in the place of x again. I'm going to put my replacement values in parentheses, and I think that's important, especially when the replacement values turn out to be negative. So using my order of operations, please excuse my dear Aunt Sally, I'm going to do this exponent first. 3 times 3 is 9, plus 7 times 3. Then I'll do my multiplication. So this is 9 plus 21, which gives me 30. I can do this on my calculator also, so I'm going to clear it. And I have open parentheses 3, close parentheses, x squared, which is over here on the left-hand column, plus 7, open parentheses 3, close parentheses. You can see up here that this looks very, very much like what I wrote down. Hit enter, and there's my 30. So the calculator is by far faster. Oops. And periodically you're going to see funny things on my screen. That was a picture of my son when he was about 6 years old for Halloween. All right. The next thing we're going to do is evaluate another expression. This one is x squared minus 11 parentheses x minus y. I have two different variables. In the place of x, I will put 7. Open parentheses, 7 squared minus 11. Open parentheses, 7 minus 3. Order of operations says to do parentheses first. Now, it's honestly not talking about this first parentheses here because this is just an exponent. It's talking about these parentheses. So I will do this first. 7 minus 3 is 4. Implied multiplication gets a dot now, and I write it down. 7 squared is 49 minus 11 times 4. This is 49 minus 44, which is 5. The value of number 2 is 5. Let's suppose I go to my calculator. You can clear that last entry by pressing clear if you want to. So now I'm going to put open parentheses 7, close parentheses, squared, minus 11, open parentheses, 7, subtract 3, close parentheses. This is your subtraction button. This is your negative sign button. So press enter, and there's your 5, much, much faster. All right, our next problem, problem number 3. If I can do some scrolling, which I don't seem to be there. There we go. Now I've scrolled. I'm going to evaluate the numerator first and the denominator second, and I like to do that when I have what looks like a fraction. So the numerator, I have 2, the value of x is negative 2, plus the value of y is 4. 2 times negative 2 is negative 4, plus 4, it looks like the numerator's value is 0. The denominator, let's see, for the denominator I have the value of x, which is negative 2, times the value of y, which is 4, minus 2 times the value of x, which is negative 2. This product is negative 8 This product, I'm treating this as a negative times a negative, so that becomes positive 4. The denominator's value is negative 4. So this entire expression is 0 over negative 4. 0 divided by something is 0. So the answer to number 3 is 0. All right, the next thing we're going to talk about is the sets that fall within the real numbers. Now this chart is available in your textbook, but I've just grabbed it and put it in these notes. The first set we're going to look at are the natural numbers. They're right up here. They usually use capital letter N, and these are the numbers that we use for counting. As a matter of fact, sometimes the natural numbers are called the counting numbers. The next set of numbers is the whole numbers. The whole numbers, and this is the way I remember it as a youngster, is that the whole numbers contain the whole. But what it really is that you add the concept of 0 to the natural numbers, and that builds the whole numbers. Then we look at the integers. The integers are the positive and negative values. So we've got the negative whole values, the positive whole values, and 0. These are many times the numbers that you see on a number line, but they are by no means the only numbers on a number line. The set of integers includes the negatives of the natural numbers and the whole numbers. So 0, positive natural numbers, and then put their opposites. The rational numbers, these are the set of numbers that can be written as a ratio. Numbers that can be written as fractions. Now they might not start out looking like fractions, but they could be fractions. So any positive whole value, any negative whole value, those could all be written as fractions. Things like all the decimals, they can be written as fractions. Even the repeating decimals can be written as fractions. So all of these over here represent some examples of rational numbers. Irrational numbers cannot be written as fractions, and they are things like square root of 2, the negative square root of 3, pi, even though it is a non-repeating, non-terminating decimal. Those are irrational, and you can think of them as the crazy numbers, those that behave irrationally. Here's another picture that helps you think about the organization of the real numbers. We start out with the natural numbers. In this picture that we're looking at here, you can see that the natural numbers fit inside the whole numbers. The only thing the whole numbers have that the natural numbers do not have is 0. I'm going to try to make that little thing go away. All right, I think it did. Then the integers have the negatives and the positives and 0. The rational numbers add in all the fractions and the decimals. The irrational numbers are those crazy numbers like the square root of 2 or pi. The irrational numbers plus the rational numbers together make up the real numbers. One last little picture that might help is that the natural numbers, which are the counting numbers, fit inside the whole numbers, but there's also a 0 in there. The whole numbers fit inside the integers, but there are also the negatives in there. The integers fit inside the rational numbers, so think of the integers as the number line with the negatives, positives, and 0. The rational numbers holds all of those, but also adds the fractions and the decimals. Then over here, the irrational numbers are the crazy numbers. Put them together and they make up the real numbers. Now, we've done all of that to try to answer literally one question. So let me try to get a little more space. right. It says, list all the numbers from the given sets that are in the natural numbers, then the whole numbers, and so on. In my math lab, this will be a drag and drop activity, but in here, I'm just going to make a list. So, suppose I'm talking about question A, which is the natural numbers. What's in the natural numbers? Natural numbers are counting numbers. You do not count with negatives. You do not count with fractions. You do not count with zero. You do not count with decimals or square root of 3 or pi. But the square root of 64 is 8, and that is a natural number. So I will put the square root of 64 in that group. B, the whole numbers. The whole numbers, first of all, they do contain anything that was a natural number and 0. So we will add 0 to that set because the whole numbers also have, quote, the whole. C, what falls into the set called the integers? Oh, I used I, but typically they use letter Z for integers. You don't have to worry about that. All right, everything that is a whole number is an integer, so I can put square root of 64 and 0, but any negative whole values are also integers, so as I look at my set of numbers, it looks like negative 11 will fit into that set as well. Then D is the set of rational numbers. Okay, and I'm calling them the rational numbers. Sometimes those are called Q. Q for quotient. All right, all of the integers are rational. The square root of 64, which is really a weird way to write 8, and 0, and negative 11, they are rational because if you put them over 1, they are still numbers. Any fractions and decimals will be added to that. So negative 3/5 and 0.1. That makes up all of the rational numbers. Then part E is the irrational numbers, usually an I with a little lowercase r, and those are, the irrational numbers are the crazy numbers, so that would be the square root of 3, because you can't take a square root of 3 and get a nice number like you could with 64. And then we have pi. Those are irrational. Final part is the real numbers, and we typically write a cursive capital R, or sometimes we will write an R with a double back on it. And everything up here, this entire set, is the real numbers. It does not matter about the order you write them down. So I'm going to put negative 11, negative 3/5, 0, 0.1, square root of 3, pi, and the square root of 64. Because if you combine the rational numbers and the irrational numbers, everything is real. Okay, so just thought we should take some time to talk about sets of numbers. The next thing I'm going to show you is a chart about the properties of real numbers. I'm not going to spend much time on this because you should have gotten it in a previous course, but the first is the commutative property of addition and the commutative property of multiplication. These say that A plus B is the same as B plus A, or A times B is the same as B times A. Both of these have to do with position. That the position doesn't matter. You can commute or change the position of the quantities without changing the value. The next two are associative. These all have to do with changing grouping. So if you have 3 values to add, you can add here the 8 and the x first, then add the 3, or add the 3 and the 8 first, and then the x. Either way, it doesn't matter. You're changing the grouping. Same thing for multiplication. The distributive property of multiplication over addition says that if you have a number on the outside and a sum or difference inside, you can distribute that. So this is going to hand out multiplication to everything that's inside. You just need to be careful with your signs. The identity property of multiplication, the identity element of multiplication is 0. If you add 0 to anything, you get what the anything is. The identity property for multiplication says that if you multiply by the number 1, you get what you started with. The inverse properties for addition and the inverse property for multiplication. For addition, it says that if you add opposites, you get 0. The inverse property says if you multiply, the inverse property of multiplication says if you multiply reciprocals, you get 1. So the inverse properties for addition and for multiplication really are quite different, but they both end up with an identity. All right, let's look at these problems. Select the property. 1 plus negative 9 is the same as negative 9 plus 1. Well, what's changed? Only position. And when it is only position, then it is commutative property, and this one is commutative property of addition. Number 6, 9 plus 3 plus 1 is the same as 9 plus 3 plus 1. Position did not change, but the groups changed. And that means that it is the associative property, and it is of addition. Number 7, which property? All right, 7 parentheses negative 6 plus 2 is equal to negative 42 plus 14. I hope that although it's not written, this is making you think about handing out that multiplication, and that means that it is the distributive property. We use that one, we use all the properties, but we call that one by name a lot. And number 8, state the property illustrated. 1 over d minus 13 times d minus 13 equals 1. This quantity and this quantity are reciprocals. And when you multiply reciprocals, you get 1. That is the inverse property of multiplication. An easier example would have been something like 2/3 times 3/2 is 1. When you multiply reciprocals and get 1, that's the inverse of multiplication. All right, so even though I've only given you questions over a few of the properties, you should be familiar with all of these. All right, moving on. Now we're going to simplify expressions. And let me do something to this. Wanted to see about getting some lines on here. All right. The first, when we simplify, when we go back, there are at most 2 steps, and this is the order. If the distributive property is called for, then I use it. If there are like terms, I do that secondly, combining them. So let's look at number 9. I have 3 parentheses, 2x plus 4, close parentheses, minus 5. This is not an equation. This is not an equal to statement. I'm simply going to use these 2 steps, 1, 2, to simplify. The distributive property is called for. 3 times 2x is 6x. 3 times 4 is 12. And I have a minus 5. Step 2 says combine like terms. Well, I have constants. Constants are alike. Use the sign in front of them. That's a positive 2 and a negative 4. And a negative 5. I'm going to subtract to get 7. So this is equal to 6x plus 7. Because the bigger one was positive, the sign on the 7 is positive. I did not do an equation. I did not get a solution. All I did was simplify, which is kind of a cleaning up process. Let's look at number 10. I have 7 parentheses 8x minus 7 close plus 10x, and I'm supposed to simplify. Well, the distributive property is first. 7 times 8x is 56x. 7 times negative 7 is negative 49 plus 10x. This time, the 56 and the 10x are the like terms, so I can combine those for 66x minus 49, and I believe that is all I can do to simplify that. Number 11, this is the last of our just simplified, and I have 9 parentheses 7y minus 8 close parentheses minus parentheses 7y plus 4. Well, I have a case of the distributive property here. That will give me 9 times 7y is 63y. 9 times negative 8 is negative 72. Now, over here we need to be careful. There does not seem to be a number in front of the parentheses, so I realize it's an invisible 1. It's a 1 and the sign is negative. So I'm going to be very careful, and I'm going to distribute a negative 1. Negative 1 times 7y is negative 7y. Negative 1 times 4 is negative 4. Now, the y terms are like terms. Positive 63, negative 7 gives me 56y. Negative 72 and negative 4 gives me negative 76. So I distributed the property first and then combined those terms that were alike, and this expression is the simplified version of this expression. All right, the last problems that we're going to do in this lesson are solving equations. And I grabbed a little statement that I typed up myself about solving equations. This is not the only way to do it, but it is certainly a workable way. The first thing says, if there are fractions, multiply all terms by the least common denominator of the fraction. And this works also for decimals, but we usually use a shortcut. Then simplify the left side, simplify the right side. How do you do that? Distributive property, combining like terms. Question, do you have variables on both sides? Use addition or subtraction to eliminate the smaller or eliminate the term on the right side. It's your choice. Then focus on the side where the variable landed. If there is a constant, that's a plain old number, added or subtracted from the variable, use addition or subtraction to eliminate it, isolating the variable term. Now you have a variable term on one side and a constant on the other. Divide both sides by the coefficient of the variable. All right, I'm going to copy down this problem for number 12. It says 10 minus 3 parentheses a minus 1 close equals 5 plus a. You certainly don't have to do this, but I'm going to kind of draw a little wiggly there, and I'm going to draw a better wiggly there. That is the barrier between the left side and the right side. In my steps, it said if you have fractions or decimals, take care of that first, but I don't. Step 2 said to simplify on the left side. Okay, I have the parentheses make me look and say, ooh, distributive property. I have 10, negative 3 times a is negative 3a. Negative 3 times negative 1 is positive 3. Can I simplify a little more on the left-hand side? Yes, I have like terms. So I have a 10 plus a 3 is 13 minus 3a. It took me 2 steps, but I simplified the left side. The right side cannot be simplified, so I just copy it down because every line of my equation has to have a left side, an equal sign, and a right side. The next step, go back up here and review them. Do you have variables on both sides? Well, yes, I do. I have a 3a and I have an a. It is up to you. Some students are taught to always eliminate the smaller, negative 3a versus positive 1a. You would eliminate this negative 3a because negatives are always smaller than positives. Other students are taught always eliminate the variable on the right. Do whatever you were taught. I'm going to choose to eliminate this a that's on the right, so I'm going to do that by subtracting a from both sides. I'm going to bring down my 13. Negative 3a and negative 1a is negative 4a. Equal sign, 5, and those were inverses. That's why we studied that idea of inverses. Now, I've gotten all the variables on the left, so I need this negative 4a to be by itself, which means I need to get rid of 13. So I'm going to subtract 13, which is its inverse. It's gone. Negative 4a is equal to negative 8. And then once you've got variables on one side and constants on the other, so here's a variable term, here's a constant term, divide by the coefficient of the variable. Do not change its sign. If it's negative, divide by negative. If it's positive, divide by positive. I'll divide both sides by negative 4. Negative 4 divided by negative 4 is implied 1a is equal to, and that's a 2. In my math lab, I would choose this choice and I would put in a 2. All right. It looks like number 13 has some fractions in it, so I'm going to have to use that first step. So I have 5/6 x minus 2/3 is equal to 1. You're going to find the least common denominator of the denominators. The least common denominator of 6 and 3 is 6. You want as small a number as possible, but all of the denominators have to divide into it. So I chose 6. I'm going to multiply 6 times 5/6 x minus 6 times 2/3 equals 6 times 1. Both sides have to be multiplied by that number. And you're going to figure out each one of these little products. Now I'm going to use that idea that this 6 and this 6 divide out, and I'm left with 5x minus 3 goes into itself once, but 3 goes into 6 2 times. So I have 2 times 2, which is minus 4, equals 6 times 1 is 6. Now I have an equation with no fractions. I don't have variables on both sides. I'm going to add 4 to both, crazy writing there. I'm going to add 4 to both sides. I end up with 5x is equal to 10. Divide by 5, divide by 5, x is 2. So I got a nice answer. X is 2. Do not expect all of these problems to turn out to be nice whole numbers or integers, because they might not. Number 14, I have a decimal. I have 0.50x plus 0.25 times 70 is equal to 32.5. All right, in this case, I have decimals. This is 50 100ths, this is 25 100ths, and this part represents 5/10. The common denominator for all of those is 100, because remember, this was 50 over 100, this is 25 over 100, and this one was, I'm going to leave off the 32 part of it, but the fraction part is 5 over 10. 100 is the common denominator. Now, a shortcut, when you multiply decimals by powers of 10, you move one decimal point for each of the zeros. So in other words, I'm going to move the decimals 2 places each. So I have 1, 2, that becomes 50x, plus 1, 2, that becomes 25 times 70, equals 1, 2. Even though I didn't have a number there, I'm going to need to fill in a 0. This is now 3,250. I did not move the decimal on the 70 because it's part of a product, and when I multiply the 25 times that, I will be affecting the 70 then. So I have 50x plus, let's see, 25 times 70 is 1,750 is equal to 3,250. Subtract 1,750 from both sides. That gives me 50x, that's gone, is equal to 1,500. Divide by 50. Divide by 50, and I got another nice answer. X is 30. All right, next problem. I have 3 parentheses 6x plus 4, close parentheses, is equal to 18x plus 12. I don't have any fractions or decimals. This little barrier line is certainly optional. I'm going to use the distributive property on the left-hand side. 3 times 6x is 18x. 3 times 4 is 12. Equal sign. 18x plus 12. Right away, you might notice that the left side and the right side are the same, but maybe you didn't notice it yet, and you were just going on with your steps. Both sides are simplified. I have variables on both sides, so I'm going to get rid of the one on the right. I'm going to subtract 18x from both sides. Variables are eliminated from the left, but they're eliminated from the right, and I'm left with this statement of 12 equals 12. There are no variables. That tells me something very, very important. This is a true statement. No matter what the value of x is, it's going to be the same on the left as the right, so it's not going to make any difference. You look at the constants, and that's true. 12 is always equal to 12. That means that any value for x will make this true, so any value for x is a solution, and so the answer is actually all real numbers. And so that's the first time I've had something that did not have just a plain old numerical answer. Number 16, I have 7x plus 5 is equal to 7 times x minus 3. Nothing to simplify on the left, so I'll just copy that down. On the right, I have the distributive property. 7 times x is 7x. 7 times negative 3 is negative 21. I have x's on both sides. I subtract 7x from both sides, and it doesn't matter which one you were trying to eliminate, you eliminate both of them, and you get 5 is equal to negative 21. That is a false answer. No matter what number you plug in for x, it's going to give you a false statement. When the result is false, the variables drop out and it's false, then the answer is no solution. over 17. I have negative 3 parentheses 5, and I hope you don't mind. I'm going to do something a little unethical. I'm going to change the variable to x. It is variable t, but so many times t gets confused with a plus sign. So in my work, I'm going to change it to x. Minus 4, close parentheses, plus 4x is equal to 5x minus 5. There's my equality. I can simplify on the left. Negative 3 times 5x is negative 15x. Negative 3 times negative 4 is plus 12 plus 4x. I have some like terms. Negative 15x and positive 4x is negative 11x plus 12. So it took me 2 steps, but I was able to simplify the left-hand side. Now, the right-hand side does not have anything to simplify, so all I'm going to do is copy it down. So I have 5x minus 5, 5x minus 5. Now, I have variables on both sides, so I choose to subtract 5x, subtract 5x. I have negative 16x plus 12 is equal to, that's gone, negative 5. Be real careful not to lose your sign. I'm going to now subtract 12 to get the constants over to the left, over to the right side. I have negative 16x is equal to negative 17. Divide by the coefficient, which is negative 16, and x is, because negative 16 does not go into negative 17 evenly, all you do is reduce or simplify your answer, and the author of the problem in my math lab will expect a negative divided by a negative to become a positive, and so this is 17/16. And so now I'm back to thinking it's t, and it is 17 over 16. That's the first time I've had what you might call an ugly answer. All right, number 18. We have 6 parentheses x minus 11, close, over 5 is equal to 5 parentheses x plus 11, close, over 6. This is what is known as a proportion. A proportion says a fraction on the left is equal to a fraction on the right. Then the cross products are equal. That b times c is the same as a times d. And we can use this concept to solve this equation. Okay, so let's take a look here and write that product down. It is 6 from the bottom times 6, open parentheses, x minus 11 equals. Let's look at this cross product the other direction. It is 5 from the bottom times 5 times x plus 11. I'm going to go ahead and multiply 6 times 6 and call this 36 times x minus 11 is equal to, multiply these, that's 25 times x plus 11. Now I'll use the distributive property. 36 times x is 36x minus 36 times 11 is 396, equal sign. 25 times x is 25x. 25 times 11 is 275. So off the recording, I'm able to do the multiplication. So it looks like I'm just doing it in my head, and I'm not. All right, now I'm going to subtract 25x from both sides to get my variables on the left. That gives me 11x minus 396 is equal to, those are gone, 275. I'm going to add 396 to both sides. I'm going to do this addition off camera, so it looks like I do it in my head. I have 11x is equal to, this is 671. I'm almost out of room. I need to divide by 11, and I get x is equal to 671 divided by 11, off camera on the calculator, I get 61. The whole point of this particular problem was that it is a proportion. So x is 61. All right, number 19, we have another equation with fraction in it. I have 7/3 plus 10/3 y is equal to 3y minus 2. There are two fractions in this. The least, whoops, hang on a minute. The least common denominator, the LCD, is 3. So I will multiply 3 times 7/3 plus 3 times 10/3 y equals sign 3 times 3y minus 3 times 2. Those divide out and I get 7 plus, those divide out and I have 10y is equal to 3 times 3 is 9y minus 6. So the equation looks pretty simple now that I have eliminated the fractions. So I'm going to subtract 9y from both sides. Remember, it's just a choice. I have in this exercise been getting rid of the variable on the right. So I have 7 plus positive 10y, negative 9y gives me invisible 1y equals negative 6. I will subtract 7 from both sides to get that y by itself. That gives me y. Yes, it's 1y, but I'm not going to write the 1 anymore. Negative 6 and negative 7 is negative 13. So y is negative 13. Number 20. This is the last of our problems. And remember, everything in here I'm hopeful is review. I'm going to solve negative 3 times 7x minus 2, close, plus 1 is equal to negative 21x plus a 7. Well, on the left side, I can distribute negative 3 times 7x is negative 21x. Negative 3 times negative 2, negative times negative is positive 6, plus a 1. I'm going to finish simplifying. I have like terms. I have negative 21x plus 6 plus 1 is 7. Going to bring down this right-hand side because there's no simplifying to do. So I'll write it down twice. Maybe you notice something right now, maybe you don't. You say, oh, I'm going to get rid of that negative 21x by adding 21x to both sides. I was getting rid of the x term on the right, and it turns out I got rid of both of them. And so I have to look at the leftover statement to determine, is it true or is it false? It is true, which means the answer is all real numbers will make this statement true. If it had been false, it would have been no solution. But because it was true, it was all reals. So here we go. So that is a review of some introductory topics. If I scroll all the way back up to the top, which I'd like to be able to do, there were lots of topics that we covered. We had properties, we had sets of numbers, we had simplifying expressions, and then we spent the bulk of our time, we did more simplifying, we did evaluating, I'm sorry, I misspoke a minute ago, and then we spent the rest of our time solving equations. So I wanted you to just get back up to speed on those skills, and we'll be moving on in the next lesson.